Hello, everybody, and welcome to today's webinar, Automotive Sealing Solutions by Elring. My name is Amanda Goyette. I'm an admin assistant with AERA, and I will be in the back moderating today's event with my colleague, Rob Monroe.
Hey everyone, Rob Monroe here. I look after membership and technical development at AERA, and you're in for a real treat today. We've got Florian from Elring that's going to talk about shaft seals and elastomer seals in different vehicle applications. And I've had a chance to meet Florian. I met him a couple times, and I've seen him do some of his training at Automechanica over in Germany. Florian is talking to us from Germany today, so this is what's nice about these webinars is that from a technical standpoint, we can be pretty much anywhere in the world and have top level presenters like Florian to be able to come on and do trainings and webinars like this. So what I'll do is, again, anybody that's got any questions, just put them in those questions box and we'll get them to Florian for the end. But Florian, how are you doing today?
Thank you, Rob. I'm doing very good because I have the possibility to present now our training. That's quite fine.
No, super. Your camera's working good, sound is good, and we can see your screen. So we're looking forward to it. Thank you.
That's nice. So hello and welcome, folks, from my side. So my name is Florian Kitzek. I give you a small introduction about my person. I'm with Elring. Let me see. The slides are going like that. Perfect. So I'm with Elring now for more than 7 years. I'm doing trainings like what I'm doing today, more or less like around the world. The year is coming to an end, so even like my travel season's also coming to an end. That's quite good. I do a summary today, and it was really showing me high figures where I was and how many people I had the possibility to train. So this was really quite amazing to see. What I'm doing more or less like I'm specialized in bringing sealing technology more or less like to you that you know, okay, how sealings are working. This is also one point what we all want to focus today. Where I did learn it was I was grown up in my father's workshop. He told me, okay, you have to learn something else, not like how you're running a workshop. And so I was doing my own path to find my education, and I was finding my way to bring knowledge to people, and this is like what I'm doing. And I really have fun to do this like in the automotive industry, and that's the reason why I'm today here. So that's some data about me. If you want to stay with me in contact, or even like you want to find me on social media, they have a lot of possibilities later on. I will mention more to you, but now let's dig into the topics. Okay, I switch off my camera, so let's focus on the presentation. That's it. All right, so what we will see today is like the content of today. We speak about elastomer gaskets. What does it mean, elastomer gaskets? Quick and easy to explain, it's like a rubber gasket, but this is oftentimes more, and you have to understand, okay, how they are working and why they are working, and all the specs about it. Then we also see about different kind of designs. We have around of a combustion engine, even like also in the future engines, maybe we are coming up electric engines. We have also the sealing technology made out of elastomer of rubber. I will mention to you the construction, the design of the shaft seals. We will take a look about, okay, what are the types of shaft seals that exist. There are also different kind of functions, the classical design standard, and then also even like the PTFE oil seals. And nowadays there's also a springless design available. I will also mention to you, okay, what is important to know if you install this kind of gaskets, and what you have to know. And later, if you have some questions, feel free to put them into the chat box or send them later to Rob. All right, what is an elastomer gasket? Quick and easy to explain, also well known as a name as a rubber gasket. Rubber can have any kind of colors. You see, we have green, blue, brown, black, but you have to understand, okay, how it works. And before we are going deep into the topic, okay, how it works, you have to understand what rubber material or elastomer material it is. And so we're coming to the point that you have to understand what kind of material they use for producing this kind of materials. So here it's an overview about different kind of materials what we have. This is starting from NBR, and it's also going to an HNBR and so on. There's a lot of definitions for it, and this is also a kind of a way of improving of the quality, let's say, and the quality and also like the temperature range what they are working is increasing from NBR to the best one what we'll find out of rubber materials, an FPM, or better known as FKM. So that means like an NBR is starting 120 degrees maximum Celsius, and an FPM is going up to 200 degrees Celsius. So there's also difference where elastomer gaskets are produced and used for, means like the applications, because some applications needs more or less like high temperature resistance and also against any kind of liquids inside in an engine, but some of them not. And so you can also use in some applications a lower quality material, NBR, for example, or you have to go for the best DFPM. Later on, I will also show you some examples, what does it mean, but this is quite an important thing what you have to understand. And not only the temperature, this is like here, it's a step that you can see, the PTFE, it's now in the opposite direction shown. It's going up to 260 degrees, but this is only available for oil seals, shaft seals. This is also what I want to show you later. And also exists lower temperatures, but also you see different colors, and the colors is oftentimes the most asked questions. Okay, why do we have different colors? And people think, okay, the color has also some point about the temperature resistance, and this is not true, because more or less like the color is given by some particles inside in the elastomer, so you can give any kind of material any kind of color. That's quite simple. So it doesn't mean like, okay, if you have a green gasket, this is more or less like high heat temperature resistance. This is more or less like another background, but I will explain you later more. Okay, to understand about this elastomer raw material, this is also a lifespan what this kind of gasket has. So it means doesn't matter what kind of gasket we are looking. This is like a typical lifespan ranges about 5 to 10 years. And this is under normal operation conditions. That means like if you have influences from outside, like extreme temperature, aggressive fluids, mechanical stress, or something like that, that means this has a big influence about the lifetime of this kind of gasket. And so in this case, it makes stress to the material. And if it's stress to the material, then also the lifespan is much more smaller in this case. So that means like, keep in mind the lifetime of an elastomer gasket is something in between 5 to 10 years. So after 5 and 10 years, what will happen? In the beginning, it's getting, this is like what you see here, this is getting smooth. There we have the functional, then the midlife, we have a minor deformation. So it means like it's getting compressed. This is also in the picture what you see here. It's getting flatter and flatter. And if it's getting too flat and too old, then it's getting hardened, it's get cracked. And then more or less like what it will happen, you have a leaking. And this is like the point what happens, because this is like if you have a valve cover gasket or you have an oil filter neck or you have an oil seal, doesn't matter, everything is made out of elastomer. It starts with leaking because the material as itself loosens the softener, and it's more or less like no possibility to work in a proper way as it should be. And this is really like the point why some gaskets are working. And now we're coming back to the material stuff. Some applications are designed for some materials, and some application needs a better material. And this is like really the point what you have to understand and you have to know. And that's also sometimes the reason, okay, why one gasket or one oil seal is working in one application in a good way and the other one is not working in a good way. But let's take a focus about valve cover gaskets. Valve cover gaskets, they have also a special design, and you have to understand, okay, how they are working, because the gasket is not only a flat rubber material, what you put into a groove, which is putting around of a valve cover. No, it has also a defined shape, as you see. And also this kind of valve cover gaskets has a functionality, because this rubber material is not more or less like used for applications between plastic parts and metal surfaces. This is the proper sealing function for this kind of seals. So that means like they are used for that. But that they are working in a good way, they have to install it in the right way, and there's also, you have to know how they are designed. So you see the seal here in the valve cover, there has a top and a bottom line. This is like what you see here, and we have also here some distance elements inside in the valve cover. And on this top layer, we are sealing against a metal surface, and the lower part, this is sitting inside in the valve cover as itself. So that means like oftentimes there's also sometimes a possibility that you put a valve cover gasket in the wrong direction inside into a valve cover. This is what you should really take care, that the sealing lip is really going to the metal surface, and the bottom part is going into the valve cover part. And then you also see the spacers. The spacers are necessary because we don't want to have close to each other the rubber material and the plastic material together, because how the material is working, it's working by the softness. So it means like if you compress the material with the right defined torque U, then it works in a proper way. Because what is possible with this kind of gaskets, they can also more or less like working in a high flexibility way, and also remove more or less like movements from the plastic parts and also to the metal surface, and also makes a noise vibration harness. So it means it reduces noises inside in an engine. This was also one of the mostly benefits to use nowadays some elastomer gaskets. But not only the elastomer gaskets are used there, we also have this not on valve covers, we have this also on what I said, like on an oil filter neck housing. There's also used the same design, but here we have on top and the bottom more or less like the same layout of this gasket. And also every kind of elastomer gasket, we find this distance elements here outside that you're keeping places, space between the rubber part and, or maybe even sometimes also used for metal between there. What is 100% not recommended, and this is oftentimes used for any kind of workshops, they want to apply here on top or even like in between any kind of liquid sealant. If you apply there any kind of liquid sealant, you take the space away, and you take also the flexibility of this gasket away. So it means like you take the whole function away. This is something what you should avoid. Don't apply any kind of RTV with elastomer gaskets. This is really not recommended. It exists some defined spots on some valve cover gaskets. I will show you later more where it's allowed to apply something like this, but in general, don't apply something. It's not something what you support a gasket, you work in the opposite way. So really avoid this kind of situation. Okay, but where are used this kind of elastomer gaskets? For sure, nowadays they're used for valve covers, oil pans, for intake manifolds. Very a common thing. This is like here on top. That's the intake manifold. Also water pumps and timing covers. This is also one classical thing. This is a timing cover gasket because they are working quite good. Intake manifolds nowadays also made out of plastic. The timing covers doing like the same. Oil pumps, oil pans, even like used here also elastomer material made out of plastic. And this is quite the right proper sealing solution. But as you see, the colors are different. Intake manifold gaskets are mostly used the red and brownish color. So this is like the color what you see here. Oil pans are oftentimes black, even like valve covers. But also some examples, what I can show you is like if we take a look on water pumps. For example, BMW is using for a water pump gasket the green color, and they use this by purpose because they said, okay, we want to have in our production for engines parts defined colors that more or less like the person who is assembling all the parts knows, okay, green is water pump, brown is more or less like, or red is like intake manifold, black is a valve cover, and so everything is clear. But if you take a look on Audi, for example, VHG, they're using black for water pump, and this is nothing more or less like defined by the material. It's only defined by the OE more or less, like what color do they want to have for each kind of pump, they can get it. So this is quite an easy thing. So this means the black one, as you see here, this is not a plastic part, it's a metal housing, but also here on this metal housing is used with the same design elastomer gasket. Some examples, and this is now coming back to the part of which kind of materials are working for which kind of applications and which maybe not, is a classical example out of the BMW world. Because if some of you are use more or less like or familiar with some BMW engines, then they also, all of you knows this oil filter gasket. And this oil filter gasket was in the beginning produced out of an NBR material. And this HNBR material, and this HNBR material was not resistant for a long lifetime against this kind of conditions. So it means hot temperatures, oil, cold, warm, all the kind of situations is not really suitable for an HNBR material. And what happens in the end, the gasket gets very fast old, gets hard, starts with leaking. And the starts with leaking was based on the material. So there's a solution for it in the market, and the solution, it calls like an FPM PX. That is like the best FPM material what you will find in the market. So that means like if you replace the same gasket to this FPM material gasket, you cannot see it from outside. This is also very important information. You cannot see from outside the material what kind it is made out of it. Is this an HNBR or an FPM? You have really to check the data sheet. Okay, what is used for? And here, for example, this is the replacement number, is the OE number, this is our number, and this is FPM PX. And if you use this gasket instead of the HNBR, the problem is solved. Yeah, that is like a solution for it, what I can tell you. The other example is also coming back to the elastomer gaskets and coming to also applications which is not this kind of rubber gasket which is flimsy and you put it inside into a housing, because also the timing chain covers also used with a metal tray, and also there is addicted or it's vulcanized to this kind of frame. There's an elastomer material, also same material what we know. And this is the same functionality. The only positive thing here is like the metal carrier, it keeps the gasket in the right spots, that the gasket cannot mislead, more or less like the sealing function. But also again, what people are used to, they want to apply here an RTV on the surface, and this is like the result that the gasket as itself has no possibility to work in a proper way as it should be. And in the end, they will lose more or less like the right place to seal, and then it starts again with the sealing. It exists some defined spots, even like on that kind of gasket. This is like the areas here on top. That means like, because if you take a look on the engine block, this is the head side, this is the block side, and here underneath it comes the oil pan. So it means like we have here the possibilities, because we have different kind of parts of an engine are coming together, that we have a leaking. So if you find on an elastomer gasket some rips, these are here some rips on this kind of gaskets, this is a defined spot where you have to apply one drop of RTV. And this is very essential that you do something like this, so you can avoid any kind of leakage out of this kind of oil seals. So in this case, put one drop here, and even like here on the T-spots, how we're calling this, that is quite fine, that's allowed, there's no problem, but not on the other spots. This is really something what we don't want to have. Another example is also, if you take a look, this is also oil filter pan, oil pan gasket, which is also covered up completely in elastomer with an inside metal carrier. And with this inside metal carrier, there's also not necessary to apply any kind of RTV, because in the end, you will crack more or less like this gasket. And again, it is also very necessary that you not over tighten the bolts, because if you over tighten the bolts in some spots here around of the oil pan, then it will happen that you compress the material too much, and on some spots where it don't tighten up and maybe in between two more or less like bolts, there's a high possibility that there is starting the leaking with the oil. So go with the right torque. Roughly over the thumb, we can say it's something between 10 to 20 Newton meters. So this is like this kind of maximum Newton meters what you tighten up some bolts where they use the elastomer sealing technology, but check really the specs from the OE that you are really in the right order, tightening up some bolts and they are fitted and fixed like as it should be. So another topic which is also made out of elastomer, this is our oil seals. And the oil seals, what we learned is rubber material, so that's like the same, but here we have also the new material, what it calls the PTFE. And this PTFE material was invented more or less like by the heavy duty truck segment, because you have to know why materials was changed over the years. There's one big reason and one thing what you have to know, why even like ancient sealing technology and materials like from cast iron blocks going to aluminium engine blocks and so on, reducing of downsizing, capacity going down and everything like that, was driven by the emissions, so regulations. That means like everything has to be going down with the fuel consumption and reducing the CO2 emissions. And based on this, they were searching for any kind of possibilities to reduce friction. And if you reduce friction inside in an engine, you can also save more or less like fuel. And the fuel saving was in trucks a lot, because they can use for PTFE oil seals, if they use them in that kind of engines, 0.3% of fuel. So for a truck which is running more or less like a lot of miles a year, there's a lot of savings. For passenger cars, it was not so big influence, but nowadays they have also another sealing solution, what we will also see there. But before we check how the oil seals are working and how you install this, you have to understand how they defined, because there's also a German industry norm, and this German industry norm is defining how the oil seals looks like. And they're starting like with this kind of letters, what you see here. We have A, AW, B, C, AB, and AWB. And what we take a look is about the shoulder of an oil seal. And this is like here in the cutted draw, we see here, this is the shoulder, what you see here. We have here, this is our spring. We have a sealing lip. This is our contact face. I will explain you later more in detail. But now we focus only on the shoulder. And the shoulder is here flat. It's a little bit rubber coated. That's quite fine. Here we have some waviness. This is one of the reasons why we said this is shape A, is with rubber coating. Shape A and W means like we have outside here a rubber coating on top with waves. Then exists also rings like they have no coating outside, only a metal shoulder, which is called B. Then you have a cassette rings. That's also common in some heavy duty applications, or even like Duramax engines and so on. They have also these cassette rings. But then also exists the hybrid version out of it. So it means like the hybrid between A and B, that is like a little bit metal, a little bit rubber, and that's it. And also to finalize this kind of things is we have metal, we have rubber with a waviness, then it calls a AWB. Why I explain you this, if you check a box from our side, there you will find a code on it, and the code is defining what kind of oil seal it is inside. Even the same coding is also written down in ACES Pies, in a dimension table. Everywhere you will find this coding, and if you don't know what it means, then you have no clue what you're looking for. So that is the reason why I give you now this knowledge. But this is not all. This is only the outside shoulder, but there's also more things on an oil seal. And more things means like we have also a dust lip. So what means a dust lip? The S is coming here because this here in front is a dust lip. What a dust lip is doing, I will explain you later in detail. But here's the same story. We have AS, we have ASW, we have BS, and so on and so on. So it means like if the S is coming, then you know that's a dust lip. And now it gets very fancy because you cannot have only one dust lip. You can also have two dust lips. That means we have AS2, we have AS2W, and so on and so on. So not losing here the time, but this is like, if you check it, the first digits, or the first letters more or less, like it's like defining how the oil seal looks like, if they have a dust lip or not. So, but now we're coming more to details, okay, how the classical oil seal is running and how they are working. So the classical oil seal is also a cutted view of this oil seal. We have here outside our shoulder, we learned we have a little bit metal, we have a little bit rubber. That means like it's an AB. That's no W because we have no waviness. And this is sitting inside this in a housing inside in our cover, whatever. We have here in front our dust lip. This is what you did see. And we have here our contact line. This is our sealing lip. This is our spring, which is putting a pressure against this sealing lip. And oftentimes the people thinks, yes, this spring is doing all the job. all the work, but this is not true because 80% of the work is done by the elastomer and only 20% by the spring. So it means like if the elastomer, what we learned, is no more good, it's getting old based on temperature, based on lifespan, everything like this, then it starts with leaking. And that's the reason. It's no influence if you are tightening up more the spring. This is not really the right solution for it because you have to understand how this ring is working. And this is what I will give you now, this knowledge. Okay, so the ring is installed inside in our engine. We have here our oil side, and the oil side, it's keeping our oil inside in the area where it should be. And we have one contact point here to our metal surface, and we have a elastomer material. And this elastomer material between rubber and metal, we need all the time a kind of a lubrication. Yeah, and this lubrication we use in this kind of technology from the inside. So the oil from inside we use here in between of the gap of the metal surface to our rubber surface, and keeps more or less like the parts lubricated. But what we don't want to have is from outside or any kind of leaking to the outside. And how we can do this is means like we put, or we creating here outside an air pressure who is pushing the air, or more or less like the oil, back into the air where it should be. But more details later, how it works in detail. We also have here outside a dust lip, which oftentimes keeps all the dirt from outside here. That's not going here in between, because this is what we don't want to have. And it's also not good for the function here. But take a detailed view, okay, how this is now working with our metal surface and even like with our rubber material. That means we are pushing our oil from inside here around, and as you see by the arrows, it's going in a circling direction. And from outside, we have here a kind of a vacuum effect. This is pushing the air against the oil, and keeps us on the way that the oil is not spreading outside. It's keeping the oil inside in the oil thumb as it is. But how can we do this? And we do this by a twist. So the twist outside of an oil seal, these are some ribs here on that surface. I will show you later some real pictures about that. But these ribs are creating, by the rotation of the shaft, some air pressure, which is pushing our oil back into the air where it should be. But this is like a very necessary point, that you have to know in which direction your shaft is running. And by the direction of the shaft, and this is also what you will find on the packing of this oil seal, you have to take a look on the shaft if it's running to the left-hand side or even to the right-hand side. And based on this information, you have to choose the right oil seal. Otherwise, this function, like pushing the oil back, is not given to this oil seal. And maybe this is the reason why the new oil seal is also starting with leaking. We have not only left hand and right hand, we have also the alternative twist. So it means it can also go in both directions. Like the same example is like on shafts, on transmissions and so on. There's a possibility that you have both directions, but on engines, like on crankshafts, camshafts, they are always going in the same direction. There's no possibility that something is going in the opposite side. So, but now we see we have now an ASW LD. That means we have here, as in our example, we have rubber, we have waves, we have a dust lip, and we have a left-hand twist. This is like the twist what you see here. This is how the oil seal looks like. What we need all the time is like lubrication from the first time. So we have to put oil here on the sealing lip. This is necessary and essential. If we don't put oil on it, then it could happen that we have immediately a thermal overload on the sealing edge, and that means like that our sealing edge is burned away, and then the new oil seal is also broken down, maybe starts immediately sooner with a kind of a leaking. So this is something what you really should avoid, that you're starting any kind of engine without lubricating the oil sealing lip with thin motor oil or any kind of silicone spray, but don't use grease. Later more, why not? This is a very essential hint from my side. But what happens all the time if you install an oil seal, you will have this kind of grooves, because the material gets hard. The material is working against a metal surface and is pushing the metal to the left and even to the right side. So that means like if you install the new oil seal on the same spot, maybe it doesn't work because the diameter is smaller. And so in this case, there's recommended that you put the oil seal in another spot. You go more in or you go more out. That's one of the possibilities, but sometimes this is not possible because it's fixed inside in the housing. Okay, what's to do? There's also a solution outside in the market that calls a repair sleeve. So this repair sleeve is a very thin metal piece what you can put here over the shaft and directly over the spot where you have more or less like this groove on the surface. And then the benefit is you can use the same size of oil seal. You have not to go a bigger version or a smaller one in this case from the diameter. You can really go with the same size. And this is quite the nice benefit if you install the sleeves, then you can really save more or less like the crankshaft and even like can go ahead with the repair. So this kind of product exists not from us. This exists from MSI, Kolbenschmidt, maybe if you know it, or SKF. Both of them are offering this kind of repair solutions. I only have good feedback about this repair solutions, and it works quite well. It exists in any kind of diameter. So if you're searching for the right one, check out the web page of SKF or MSI or Kolbenschmidt to find the right, which is matching to your shaft. But how you install now the oil seal in a proper way, this is quite simple and easy. And I think nothing special for workshops, because in the beginning, for sure, you have to check that the shaft is in clean conditions, no cracks, no defects. You have to clean everything. It's highly recommended to use always some protection sleeve, that you are not putting the oil sealing lip over sharp edges, that you destroy the new oil sealing lip. Use on the inside some oil, thin motor oil is quite fine. It's not a problem. Don't use grease. Then press the oil seal equal in, very equal. Check by the housing if it's really fitting equal next to the housing. Also recommend is like a press in tool, some special tool where you can use it, that it's going equal, and then check it. And if everything is in the fine conditions, you can start the engine. There's no problem. So I was mentioning don't use grease. Why you don't use grease? Because grease is too sticky. And if it's too sticky, then it maybe will block our twist outside the design of the outside flank. And this is something what you should avoid. For sure, it makes a lubrication, but this is not really recommended to use it in this way. So go for thin motor oil. It's quite fine. All right, so this was the classical oil seal. Now let's go for the future technology. That's a PTFE oil seal lip. How does it work? That is necessary that we check here the cutted view, and the cutted view means like the outside of this oil seal is also made out of a classical elastomer material. We have also a metal piece inside for sure, but now we see this here around. This is something different, and this is our PTFE sealing lip. So in the beginning, the first thing what we are missing is like a spring. There's no spring anymore because we don't want to press anymore against the surface. We lay on the surface, so like a track lip. So that's perfect. We have no pressure, and this is how we reduce the frictions. The big benefit of PTFE, this is like a self-lubrication material. So it means we don't need the exchange from inside to the sealing lip to the surface with some oil. So this is handled by the material. So this is the first thing. And even like what you see, we have more contact possibilities to our metal surface, and that means that we have not this kind of groove situation, not so hard this groove situation on the surface as we had before with our elastomer gaskets. So in this case, this design is completely different, and also what I was mentioning is like the temperature resistance going up. We reduce the friction. This was really a quite good technology what was invented in the 1995, something like this, came up. The PTFE oil is quite fast. So that means like this is more or less like a common material what nowadays you will find. But what was a headache for workshops, the installation of these oil seals, because they was installing this kind of oil seals in a classical way, as they was well known over the years, because they just put it in and use also oil and starting the engine. And this is more or less like the reason why they failed it many times, because you have to know these PTFE oil seals are very sensitive about any deformations, about scratches, and so on. That's the reason why the oil seals are getting delivered by some protection sleeves inside. Oftentimes you find a protection sleeve. Sometimes you can also use this for the installation. So that means like check if you get this oil seal that this protection sleeve is fitted properly inside into the oil seal, into the PTFE oil seal, because this is very necessary that you have no scratches. They are very sensitive about that. So, okay, the preparation of your shaft is quite a simple one. You have to check, okay, everything is clean, no cracks, everything should be without any oil on top and even not around. So really use some brake cleaner or something else that you're on the safe side. Shaft is completely clean. And now it comes the essential part that you also have to use some protection sleeve before you put the oil seal over the shaft. Yeah. So because really you have to avoid that the PTFE oil seal is getting any kind of defect, scratches from the edge over the shaft. That's the reason oftentimes you can use this kind of protection sleeve, but if it's available, then you can also use there some special tools which are coming or which are available in the market. And now you see this is double security for our side. Don't use any kind of oil or lubrication on the sealing lip, even not on the outside, because the material is a self-lubrication material. If you apply oil to this PTFE oil seal, it will not work. It starts immediately with leaking. So really, it must be dry on the shaft. It must be dry on the oil sealing lip. This is very essential. And then the next step will be pushing the oil seal into the end position, remove the protection sleeve, and now it comes the hardest part for workshops. Wait 4 hours until you start up the engine. Why do you have to wait? The question is quite easy, or more or less the answer. You will widen up the oil seal when you push this over the shaft. And if you widen up, then it needs time to relax the oil sealing lip to get back into the shape as it is next to the metal surface and make the proper sealing function. So this is very essential that you have to wait. This is also depending about temperatures. If you have winter time, what it's now coming up, it takes maybe the 4 hours. In summertime, it goes much more faster for sure. But with 4 hours, you're on the safe side. What means the 4 hours of starting an engine? So it means like if you have to move the shaft by hand, that's not a problem. Really low movements, less RPMs, let's say, that's quite fine. But if you really start an engine with RPM, even like with idle, this is something what you should not do. And if it starts once a time with leaking, if you don't catch up this information, didn't follow it up like what I told you, and it starts with leaking, there's no chance for cleaning, not chance for remove the old oil seal or the new oil seal and clean them and put them back in. No, you have to change it to a new one. This is really something what is completely different as the technology before. And this is still some problem for the guys outside in the market, and they will struggle still on the PTFE oil seals. That's the reason why we're doing this training, by the way. Okay, but also outside now in the market since I would say more or less like 10 years, it exists also a new version, and the new version means like the springless design. And the springless design, the material what is used now is also elastomer material. So the FPM material is also used on this kind of designs of oil seals, and the oil seal looks identical more or less like as a PTFE oil seal. But this PTFE or this springless design, what is named OF, it's coming from the German language, because even like this description is everything based on German industry norm. But it means like without spring. The benefit of this oil seal is quite simple. We have elastomer material, so we have also a quite sensitive oil sealing lip, but not in comparison with the PTFE. We have also to check that the shaft is in good conditions. It's also recommended to not use any kind of oil, because this oil sealing lip is coming slightly oiled. Yeah. And if you put this over the shaft, it's also recommended to use some protection sleeve that the oil sealing lip doesn't get any kind of scratches, defects, and then push it in the end position. and then the job is done. You can start up the engine. You have not to wait 4 hours. So this is the benefit. Also, this kind of design, because you have no spring anymore. You have this best material what you will find, the FPM. It's also reducing of the frictions. So that means this is also quite good material. And this is nowadays replaced by, or this technology replaces the PTFE oil seals. If you check today, the modern engines, they all have nowadays no more PTFE oil seal inside. They have this kind of springless design oil seals inside. It's nowadays a common material like the last 5 to 10 years, let's say. In the VHG version, it also exists some PTFE oil seals with this crankshaft sensor, which is checking all the ways, the RPMs. And if you have to install this kind of special oil seal with a housing and with this crankshaft sensor, there exists some special tool, which is very necessary, because there you have all kind of things what you can what you have to check. That means, like, on one side you have to check that the engine, or more or less the first piston, is in top dead center position. Then you have to level up your tool. You have to use your new oil seal, put them onto the tool, and then you have to tighten up or mounting it back to the engine block with the right torque cue. And then you have also to check that it's really fitting into the right position. All of this is necessary, because if you fail, if you use oil, if you don't make the right setting for the oil seal, that means like that the engine won't start up. So this is something what you don't want to have. In this case, all these kind of steps are necessary for mostly VHG versions cars which are running around the engines. Also, if we talk about this oil seal housings nowadays, this is also more and more a common design, that you have these oil seals also on the back with elastomer sealing lips, because the housing has to sealed. Sometimes it's really used RTV for the sealing purpose, but here in this especially example, there's an elastomer sealing lip on the housing. And the customer was using here some RTV, and this is something what I also mentioned to you in the beginning. This is not working out in a proper way, because what happens, it starts also with a leaking. And even here underneath, this is the position of the oil pan. He applied quite too much, so there's really a high risk that you're going here inside, and it's also blocking our oil seal. So this is something really what you should avoid. The next step is like, and now we learned about everything about our oil seals, how they are working and everything like that. But now it comes the point, before you install a new one, how you remove the old one. Yeah. So this is the more or less like still ask questions. There are common methods outside in the market. And the common methods, it's, I think everybody knows it. It's like putting or drilling a hole inside into the oil seal, take a screw, and then take some pliers and pull the oil seal out. It works, but in the end, it's sometimes a little bit critical. That's the reason I found some nice solution which is working very well, and I will give you this kind of recommendations from my side, because I use this also in my hands-on trainings outside, and every kind of participant who's seeing this in a live demonstration, he loves it and wants to have it. This is like a special tool, and the special tool has here in front a hook, and this hook is a little bit out of the line. And by out of the line, it means like you can go between the shaft and the oil seal, behind the oil seal. And if you go behind the oil seal, so it means the hook is now behind the oil seal on the metal frame, and the opposite side, you push this against to the housing. There you have the possibilities to pull out the oil seal quite easy and quick, without destroying the shaft and without destroying the oil seal so much. And it's much more easier and quicker as you're drilling any kind of holes inside and putting some screws and taking pliers and so on. So really, I can recommend to you this kind of special tool. It exists in the market. It was invented by Volkswagen, but also the company Stahlmax is producing this one. Here's the part number of it. If you like it, you can search it in the internet for it. I can really recommend it. It's quite a good tool and very helpful for the workshops. All right, so if you are looking for more information, means like technical base, I can invite you to our homepage, www.elring.com. There's available in different kind of languages, of course. And even why I will show you this, we have dimension tables, because we spoke about today about the oil seals, and maybe you're searching for a specific oil seal. Maybe you have this oil seal on your table, and there on our webpage you will find a dimension table. You can put in all the dimensions of this oil seal, and then immediately you will find here what it's made and how it looks like. That's the reason why I explained you everything about what is a shape, what is a B shape, and so on. What means WD, what is FPM. So nowadays, I think you more well known what it means like. And the benefit is if you type in here on top the diameters of your oil seal, you get a result, and on the result you can click here directly on that number because it's our part number, and then you get forwarded to our tech doc catalog, also ACES PIEs. And then you see immediately a picture, and you will find all the data about this oil seal, and you will also find an OE reference number. Maybe it's fitting to any kind of engine which you have around, and then you can really compare if this is really matching. So in this case, this is really something what is very helpful, and it's free to enter. You have not to sign up to something, and check out the catalog. You will find much more. All right, we have also social media, and if you like more or less like this presentation, we have also a YouTube channel, Elring das Original. So there you will find a lot of movies where you can check it out. There's without language, you can only watch how you install any kind of gaskets in the right way, even like oil shaft seals and so on. You will also find me on social media, Instagram, Facebook. I named Florian Kitzak Elring Trainer. So if you want to follow me, you're highly invited. And now we're coming to the important part, and this is like, if you have questions, now it's time for questions.
Excellent, Florian. That was a great presentation. Really like your images and your slideshow. Like all of your real life images are excellent for those of us that are in the field. It's a great way to see just how some of the stuff is put together. We do have a few questions. The first question I've got for you is on crankshaft oil seals, or like on vibration damper or harmonic balancer oil seals, for those engines that are not going to be in service for an extended period of time, when the oil's all gone, what do you do? Like, how should you lubricate those seals when you know that the engine's not going to be started for a long time?
Yeah, it's a good question, because this oil seals, and this is oftentimes what I also told to everybody. The elastomer has the lifetime is starting. It doesn't matter if it's laying in the shelf, if it's installed. This is a normal procedure that the softness going out of the material. So it means like there's more or less like no really solution what you can apply on it, or how you can more or less like any kind of oil on top that you can extend more or less the lifetime. So that means in the end, even like if an engine is standing, it could happen that in the end, yeah, the softness is gone away and it starts with a leaking after years. There's no really solution for it.
Okay, all right. Another question for you. If you accidentally over torque an elastomer gasket, is it possible to reuse it? Can you just undo the bolts and reuse that gasket, or do you need to replace it once it's over torqued?
If it's happened immediately, so it means like you torque it up and you realize, oh my goodness, that was a little bit too much, you can use it again for sure. But if you run like the engine for some miles or whatever, and then it starts with leaking, you realize, oh, maybe I tightened up too much, it's recommended to replace the gasket. But if it's starting during the installation process, that's not a problem. You can use it again.
Okay, all right. I've got one more question for Florian, and I know we're trying to respect everybody's time today, so if there's any more questions that you have or that come in, by all means, we'll forward those to Florian and get them over to him so he can answer those. This question, Florian, they're asking, is there an easy way to know if you should use the seal dry or if it needs to be lubricated? I know some seals need to go on dry, but is there an easy way that you can tell?
Especially with elastomer gaskets, this is what I was mentioning. The oil seals with a spring needs the lubrication, all others not. That's it. That's quite simple. If you don't find the spring inside, you'd have not to use any kind of lubrication.
Okay. All right. So that's a good way to tell. That's your easy reference then to do that. So well, Florian, I appreciate your time. I know it's just about dinner time over there for you, and your day was long past due. Again, great presentation. You're always a big help to us, and I thank you for your time. And we hope you enjoy the rest of your evening.
Thanks for having me. It was really a pleasure to present the training, and hope to see you next time. Thanks.
If you need to reach anyone at the AERA team, you can reach us at 815-526-7600, or feel free to email either myself or Rob. You'll see both of our email addresses are there. We're happy to answer your questions, and if we can't answer them, we will pass them along to somebody who can. So once again, thank you, everybody. We appreciate your time, and we hope you have a great rest of your day.